Good evening, everybody. Welcome on in. Hello, Tech. We are here on this Tuesday night to continue another round of Human Resource Machine, also known as assembly programming, because that's what it feels like. I just opened the game and happened to notice they've got an ad for another game. 7 billion humans. Automate swarms of office workers. That actually sounds fun too. Maybe later. Let's just play the game. Wait, that shut the game off. That's not what we wanted. Bring back the game. Yeah, that's pretty much the plan, Tech. Get stuck on a level forever and ever, all evening. Here, we'll see if we can get it locked in correctly. There it goes. That's what you do with assembly, though. Yes, welcome back. It's good to be back. Tick, tick, tick. Times keeps ticking. I don't know where... I'm being timed now? Okay, we've got bumps. We got incrementers and decrementers, too. Yay. For each number in the outbox, send that number... For each number in the inbox, send that number to the outbox, followed by all the numbers down to or up to 0. It's a countdown. Huh. Sure. Okay, let's do this. We're getting into some real loops now. Take a number. Then outbox that number. Then I want to make this... Oh. But minus... Oh, this doesn't do what I thought it did. On the floor. That's not as cool. Okay, so we'll put that in 0. Outbox, jump if negative. Bump 0. This needs to bump plus. Jump if 0 back to the inbox. But we also need to outbox here. I mean, I could self-contain these things, I guess. Decisions. Hey, Blake, how's it going? I think that's it. I think that's the program. You can't jump if negative with empty hands. It says the result is given back to you. Outbox. They add 1 or subtract 1 from an item on the floor. Oh, we don't have anything in our hand. We should probably read the number back in. Hey, Kata, thanks for redeeming Put on the Hat. Long time no see. How's it going? You can't jump if zero with empty hands. So what if we move this to here? Empty value, you can't. Also, hi Raiders. Hi Cash, welcome on in. Doesn't look right without the hat, you're not wrong. How you guys doing? We are programming on stream in assembly, kind of. Which is a different way of programming, if you've never programmed in assembly before. It's called Human Resource Machine. Hey Rainbow, hey Cash, hey Morgana. How did stream go today for you guys here? Let's do this shout out command so we know what you were doing. You did this in high school? Cool. Playing Minecraft. Assembly code. I mean, that is what it is, because this is labels, jumps, decrementers, incrementers. Like this isn't for loops and while loops, at least not yet. I haven't seen anything even remotely close to that. Empty value, you can't jump if negative. You can't jump if negative with empty hands. No, because we didn't do this. Okay, so we'll add the one extra command in. Stop. Copy from. How's everybody doing? Got back to streaming with some modded Minecraft today. Took a break last week. Nice. How's assembly is fascinating to you? I mean, I find it to be it's somewhat fascinating to me, but it's more I'm so glad we've abstracted past all of this. But, you know, it's still learning. It's fun. How's your game programming going, Rainbow and Cash? How's Cheese Nips? Uh-oh. Somebody didn't do what they were supposed to do. I didn't pay attention to what happened. So we got to 0. Jump if 0. Back to the beginning. I should probably pay attention. Assembly is not something you could do. Oh, you could do it. It's too advanced. No, you'd be fine. Like, it takes practice. This is true. And if you think about it the way this game is trying to get me to think about it, it's really not all that bad. Oh. See, now I'm duplicating things, and I'm not happy about that. Jump if 0 here, back to here. This can absolutely be optimized. How far in am I? I think this is my 18th year, maybe 19th, but I've been refusing to not succeed at least somewhat optimally. So in a moment here, when I complete this one, see, I passed, but now it's going to tell me that I didn't do it with the fewest commands. I could have done it with 10 and I did it with 13. Horrible. And I did it with 119 steps when I should have only done it with 82. It's not that it's impractical. In fact, this code right here might be what a compiler generates. Now, in all honesty, compilers have gotten pretty smart, so that probably isn't what would happen. But my point is, I don't know what my point is. See, in our backend developments, save data has been optimized to its peak, which comes with a ton of benefits for us. Nice. So, like, you can store more data. Is that the big benefit? Okay. So here's what we're gonna do. We're gonna just do this a second time entirely, and we're going to think a little bit more about it. So that we're going to inbox the number. We know we need to store that number immediately. Then we're not going to outbox it yet, although that is part of the loop. If the number is negative, we have to bump plus. If it's... See, I don't like that we have to use both of these. Jump if... I wish there was a jump if positive. Okay, so... Sub-zero. Sub-zero. Okay, so now we have a negative number. Oh, but see, now we have to convert it back. That's not going to work. Okay, forget that plan. Okay. It does not bring? Wait, what? Does it just make things load faster? Like, what kind of optimization are we talking about? Because that's what I'm doing now. I'm doing optimizations. Copy from 0. Outbox. Jump if negative. This would be a minus. This would be a plus. So we're up to 7 commands, which means in theory I can only use one more. So then... Then jump back to here. And then jump if 0 to here. Except we forgot to inbox one more time. When we bump, we're going to get a new number. So we have that new number to outbox. But the moment we outbox it, we lose it. This should be copy 20. So now that's 10. I think that might be right. Probably forgetting something. You're raising chaos? What kind of chaos? The algorithm that interprets our current save data has been... I gotta scroll up a little bit more. Memory usage is down, always a good thing. Performance is improved. It has instantaneous load times now, which it means we can update and decode save data in the middle of a scene rather than only at the start. Cool. So real-time saving. You know, you can use an animal on a chow. You actually meant chow. You didn't mean chaos. If you get the right spacing. I didn't know that. Pretty much instant load times are based. Yeah, so you got them down to O of 1, huh? Okay, so the good news is we got 10 here. The bad news is... we're still doing way more steps than needed. That really bothers me that we're still doing way more steps than needed. What if we... What if we move the outbox to here and get rid of the copy from? For some reason, I don't think this is going to work. Yeah, because that jump depends on us being... And we can't... so that is needed. Copy from 0. But there's nothing in our hand there. So we're back to that. Maybe I can visually see it. No. Couple frames, that's not bad at all. And the JJ bug is completely eliminated. Well, I feel like I've been eliminated. But if it's what you had to do. Is it this? We don't need to jump back to here. We can just jump up to there. I wonder if that's all it is. Probably. It sounds like something I would do. Then just show me the assembly, because by the time I get around to getting this game beaten, I'll be an expert again. Not that I was ever an expert in assembly, but I want to believe I could be. Nope. 114. Why? Why? What step are we doing that we don't need to do? Bump 0. This better not be one of those things where... I can't do both at the same time. What's this one say? Measure the number... Yeah... These challenges can be very difficult, and in many cases not possible to optimize both simultaneously with one solution, which bothers me a little bit. How do I know? That doesn't even answer the question, though. Like, why? Why is there no pause button? I have to air to pause? Oh, that'll work. He brings it over there. We run that command if we end up there, but we also run this command every time. feel like it's this jump if 0 that can be optimized, but I'm not sure why. Or... no, we need that. It's not good that I get stuck on this stuff so easily. Best completed 114 steps. I mean, that's literally 22 steps that have to be removed. Or more than that. How many iterations are there? I mean, it varies by the input, right? So somehow I can remove 30 some steps, which probably means I have a jump in here that is happening too often. Random isn't maybe the right word, but yes. Just go with yes. Because like if I 7 negative 406, if I stop, now it's 5 negative 308. So yes. I have an idea. I'm going to do this one in a new one, though. Okay, we're going to inbox it. Then, if the number is negative, we're going to do this. Otherwise, and I'm just putting this stuff in here. If 0, we're going to go back up to the top. And... if 0, we're going to go back up to the top. Okay, so then, so if it's negative, no, let's stick to if it's positive. If it's positive, we're going to bump minus. And jump back to there. If it's not that, then we're going to bump plus and jump back to here. What is this? Jump if negative. That has to be here. So we're still at 10 commands, but now we've only done the negative check once, which that should greatly reduce things. It might also err. Because we still need the... copy to 0. So this is going to add a command, which I'm not overly thrilled about. Put that there. Do it again. We skipped the 0. But the number of steps you're trying to beat is the same. Yeah, it's a little bit... You're not wrong. They do averaging behind the scenes. So there's more calculations than just the one, I think. Because I tried that. I tried running my output multiple times to see if I would get a different answer, and I didn't get a different answer. So they're simulating multiple things or something. I mean, we can add the outbox. I don't like my answer, but we'll optimize it if it works. If we need to optimize. I mean, we're at 13, so we're over on the... Oh, what did I do? Where'd we start? So the number was 0. We didn't check that. Ah, we're gonna move the jump. Get stuck in that loop. Up. If it hits 0, we stop and we break out of the loop. Okay, so let's build this the other way. We do it like that. And we put an outbox there. Which we can't. Unless we do that. What? Oh, yeah, we didn't mean to reverse. Oh, no. Yeah, see, if we reverse it, we don't get the free pickup. Ah. Okay, so that was a bad idea. Inbox, copy to 0, outbox. Jump if negative. Except we don't need that outbox anymore. So now, if it's negative, we go down here and we do this portion of the code. The breakout is if 0, which takes us down here. We then outbox the 0 and we go back to the beginning. Outbox bump 0, bump 0. So why did this fail? Because the number 0 doesn't skip right away. Yep, okay. So we need to add a jump if 0 here first. And just jump it down to the bottom. So I'm not worried about that. 82. Okay, so what we learned last night, this was really frustrating. And I don't think there's a way to find out without Googling it. But what we learned last night is that if you don't have to get both challenges on the same thing. to get the lights. So we're trying to get both lights, and each light represents one of the optimizations, I believe. And there's even a note that says, you might not be able to do this. But it doesn't tell you whether or not you might not be able to do it, which is frustrating. Fond memories. We worked hard back then. What are we doing? Multiplication. For each 2 things in the inbox, multiply them and outbox the result. Don't worry about negative numbers for now. You got labels. They can help you remember the purpose of your code. Oh, labels. That's nice. I'm not going to use them. Who needs labels? Oh, they gave me sample code? I don't want... Oh, am I gonna have to use them? Yeah, whatever. Okay, first, we're going to inbox a number. For each 2 things in the inbox, multiply them. Is it drawing? Oh, it is. Look at that. It's kind of cool. So, we're going to take in the number. We're going to put it in... Put it in hello. Then, we're going to inbox the number. We're going to copy that to... 7. How do I add the labels? Nope, that's even more confusing. Bad label. Okay. Copy to X, copy to Y. Okay. So the number comes in, 4 goes there, another number comes in, 3 goes there. Then we're going to copy from X and then our loop starts. Actually, no. Doesn't need to start. We'll just do it like this. So we're going to... if 0, outbox. We're gonna bump. Oh, I used to know these algorithms, and there is a better way to do this with more register or with other variables or other commands, but we can figure this out. So we're holding Y. We're going to Y is going to be our counter. Jump if 0 down to here. Okay, so that's going to be when we're done. We're going to bump minus Y. Then we're going to copy from X, and we're going to add X. Then we're going to jump back to here. And we're going to add another copy from... Nope, we have a problem. Ooh, the 0. Copy from 0. Okay, so we're going to take the 0, we're going to put it in equals. We're then going to copy to x, we're going to copy to y. We've got our two numbers. We're then going to copy the 0, add x, decrement y, leaving it there, but we didn't put it back into equals, so we need to put it back into equals. Bump that down. Loop that however many times we need to loop it. If 0, jump to here, but we need to copy from equals. Let's try that out. Your brain is busted? Why do you say... Not enough stuff? 5 items, not 1? Oh, we only ran the loop once. Go. And to think, this is what the processor in your computer is doing. Well, we got the answer. 15 commands, got that one. Didn't even come close on this, on the performance. I mean, there's some optimizations that could be done. You never realized you could multiply that? So what if I told you this is how the computer multiplies? It's not entirely accurate, because there is a mul command on most processor these days, and it's gotten a little bit more complicated because everything's in base 2 math. So there's some bit shifting you can do. That allows you to like manipulate with powers of 2, which is kind of fun. Some fun optimizations, but we don't have those available to us yet. I want more Dots pretzels. Question is, where's the optimization in this case? How far off were we? We'll use that as a reference point. Man, small bags of Dots pretzels not as good as the big bags. We were off by 60. So on average, we did probably like 2 commands more per loop. I think the thing that makes this most like assembly is that we're dealing with single registers, or in this case, our one dude. How do we... There's got to be... The only real loop we have is this. So there's something here that I'm not thinking about. And anybody that's watching along, feel free to jump in if you've got some brilliant idea. I'm not concerned about backseat driving here. I mean, don't go Google the answer, but copy to add. Yeah, exactly. Backseat assembly. Copy to X. I mean, one way would be to always take the smaller number. Let's do that. It's gonna make our code longer, but so copy to X. Inbox. So now we're holding Y. We're going to sub X. Not before we copy it to Y. Okay, so we now have done Y minus X. If negative, skip. Because that means Y is less than X. So we want to increment this. Otherwise, copy from X. Copy to... Wait. What are we currently holding? Nothing that makes any sense. Copy to... 0's fine. And then copy from Y. Copy to X. Then copy from... 0 and copy to Y. Okay, so why do I feel like I took too many steps to do that? So that'll take the value that's in X and reverse it, but only if it's backwards, which should mean we always loop the smallest number. Uh-oh. I think we got negative somehow. Okay, copy. How did we get negative? sub x, jump if negative. Which is fine. So, oh. No, because then the first thing we do is copy from equals, which is 0. So that's not the problem. How did we get negative? It's got to be the sub. The sub is what got us negative, but copy from x, which is that value, copy it to 0. Copy from y, which is the other number we grabbed. Copy that to x, good. Copy from 0, which is what we just saved. Copy that to y. So we're just flipping the values. That's exactly what should be happening. Let's just run at high speed again and try to catch it when it... It was 0. We gotta add a jump of 0. Try it again. Do. I mean, it's definitely faster. Took a lot more commands, though. Still not great. This is all O of n. So this is the only... or O of 1. This is all O, n... Copy from... add x. Save it. Because if we don't save it, we're gonna have a problem. I mean, I like that it does the smaller number first. That definitely was an improvement. Where's the other 30 steps? Copy from... Let's read what add does. Didn't do what I thought it would do. Oh, we gotta drag it to the question mark. Hold on. The result goes back into your hands. Add the contents of the... Yeah. And bump always gives it back to us as well, right? It's back into your hands for your convenience. Counting up doesn't solve this problem. I feel like there's some mathematical property that I'm not remembering in terms of how to make it work. Well, you know what? Unlike last night, I'm going to leave this here. I will come back and start going backwards, but I kind of just want to keep progressing tonight, so... because I have a feeling the optimization is going to get harder and harder. Do you know what zero terminated string is? Yeah, you put a zero at the end. It's a very old technique, and we don't expect you to know. So you may ask me about it if you'd like. Or you may ask an external source, whatever helps get the job done. The inbox is filled with zero terminated strings. What's that? Ask me, your boss. I understand. Add together all the numbers in each string. When you reach the end of a string, put the sum in the outbox. Reset and repeat for each string. Sure. Inbox the number. If zero, go somewhere else. Otherwise, add the number. Before we do that, copy from 5, copy to 0. So 0 is now here. Then we add whatever we're holding to 0, and we copy it back to 0. Jump if 0, then we outbox. But first we have to copy from 0. No, 0. And then we jump back to here, I think. Expected 13. Oh, somewhere we forgot to inbox. Stop. There was another jump right here. Isn't this fun? Hey, I like it when we get the size one done right away. We're off by 20. I know I said I'd skip ahead, but I wanna take a stab at it. See what we can figure out where I could have made this faster. From 0, copy to 0. I mean, if they tested 20 values, then... I mean, can I just get rid of this copy from? No. Add 0 copy. Oh, yeah, no, because it's going to be... Add 0. Jump if 0. Oh. We can drop this. No, we can't. Arrgh. Jump if 0. Jump if 0. That's the end string, so that's going to happen. Grab a number. If it's 0, otherwise add 0 and paste it back. I don't know where we reduce. Okay, that's enough. I'll run it one more time just to... "20 steps. Okay, well, for another day. Fibonacci time. Hey, Charles, thanks for the lurk. Hope you're having a good day. Back hallway is for advanced employees only. Are you sure you want to be here? Sure. Okay, good old Fibonacci. So... oh, so it wants the whole sequence? First 10 numbers? Okay, so they gave us 0. First thing we're gonna do is get a 1. So we're going to copy from 9. We're gonna copy to... we're gonna bump it. Oh, we don't even need to do the copy from. Bump to, copy to 1. Okay. So we got our 1s and our 0s. So then... I gotta remember my algorithms now. I know how to do it with a for loop. I know how to do it with a while loop. Just gotta implement it now with this. So... we need a counter. We're gonna call this C. So we're going to inbox. We're going to copy that number to C. Then we're going to bump minus C and loop back to here. Okay, so that's our counter. So 1. We're also going to oh, we don't need that. We don't need that. We do need that. Oh, we gotta make another copy. I know what I'm doing wrong here. A. We'll call this one B. We're gonna copy. One gets us inbox. Wait, for each thing in the inbox, but not exceeding that value. This isn't doing what I think it's doing. For each thing in the inbox, send to the output the full Fibonacci sequence up to, but not exceeding that value. So we have to do a sub. Okay, I'm doing the wrong programming. That's my first problem. But I think I still have to do most of this anyway. Okay. Copy to C. We have 1, 1 right here. This plus this becomes this. Nope. This plus this becomes this. This plus this. It's the iterative. I'm trying to do the iterative version of Fibby. C. I want to look at this number, but that number can't change. So if this is a 0 and a 1, so copy from here, copy to here, bump it, copy to here. Okay, so we've got those two. Instead of doing bump, we're going to do a subtract. Subtract C, and instead of a jump if 0, we're going to do a jump if negative. need to now sub-C. So the number we're holding is not what we want. What we want to do is we then want to outbox but outbox means we need the number again, so we're going to put copy to C, inbox, copy to C. Why? That's just a constant. Okay, so then we're going to do copy from B, add A, copy to there, copy from B, copy to A, copy from here, copy to here. So now B is we're holding the right number. We outbox that number, we sub C, we jump if negative, and we do it all again. That might be it. Can't sub with empty hands because we outboxed. So copy from B. Try it again. Listen to that for a while, made your brain, while driving, made your brain hurt. I'm sorry to hear that, Cassandra. I feel like we skipped. Where did we start? Okay, that's right. Wait, let me modify this 0. Okay. Why do we put that into C? Okay, we overrode it right away. So we picked the 1 up. We added those together. That gave us a 1, as it should. Does it want the 0? It doesn't want the 0. So it does that. Then we outbox the 1. $19. Jump if negative. Oh. That's not right. We have the jumps wrong. This needs to go here. This needs to go here. Hey, Silverdown. What is this? So this is the I would call it the lowest of low level way of looking at programming. So most of the time you write things like what are known as while loops or for loops or anything like that. And in this case, we don't have those structures. So we're forced to use this little dude as the middleman, and he has to move the numbers around to get him to do what we want him to do. The parallel here is that it is exactly the same way your computer works with something called registers, for the most part. I mean, it's a simplified, dumbed down version of it, but it's the right idea. So the idea here is to give it the path it needs. I don't know why I copy that into C, so that can go. So on one hand, it's programming. On the other hand, it's one big puzzle. Which programming really is just a big puzzle. So we move that. We move that to there. Good. And we outbox the 1. Good. First number's right. We pick up the 1. Oh, it's not supposed to jump to there. It's supposed to jump to... here? No. Here? Yes. But if you've ever wanted to learn how a computer thinks, this is a pretty clear-cut example of it. We're just going to add a random outbox to this whole thing. That there will always be a 1. Expected 1, but I outboxed 13. Something didn't get reset. Oh, we didn't reset everything. So when we jump back to here, we actually need to jump back to there. Let's try this again. Oh, cool. I might have to linger and watch and see how it goes. I wish you luck. It's a secret, guys. Expected 1, but I outboxed 21. Why? What did I... Okay, good. Oh, it's the next number. Let's change the rules just a little bit. Instead of outboxing here, let's copy from A, and then let's get rid of this outbox. Just take the earlier buffer. I wasn't paying attention. Here, let's do it again. Stop. 19. So it should stop at 13. During the break. Okay. Cool. Well, I will try to hang around to see it. Oh, how did our 0 copy from 9? Let's just bump B. One more time. I can grab it. I'm assuming he'll have you put it in chat, so I can grab it from there. Or get it from him later. Or watch it after the fact. Now, why did that one fail? Step back. 8. So it hit a Fibonacci number. What are the rules for this one? Up to, but not exceeding that value. So... I mean, this is a stupid way to deal with that problem. That's not what I wanted to do. I just want a decrement when I'm holding, which is not... I could make my own decrement. It's ridiculous. Did that right. So far, so good. No air. 19 or fewer. Too many. So we get rid of 2 commands, we win. I mean, we technically could reuse the 0, but that's dangerous. You see, copy from B, add A. Copy to 6, yep, that's the temporary variable. Copy B to A, old to B. We're going to use A. We can get rid of this copy from A if we move the outbox to here. Copy from 6. Copy to B. So why are we then copying from B? We don't need to. We have it. That's our 2 commands. I think. Doesn't allow links in chat. Oh, it's board game night, isn't it? Even more reason to hang out tonight. Play some board games. So we should have got the first optimization bonus, I think. There we go. Oh, I'm 5 away on the speed challenge, too. Oh, we're so close. Five away. Nope, not gonna do it. That 5-way could take hours. The littlest number. To reduce our carbon footprint, management is requesting the smallest numbers only. This is a public relations exercise. The results are going straight to the landfill. For each 0 terminated string in the outbox, send to the outbox only the smallest number you've seen in the string. You'll never be given an empty string. Reset and repeat for each string. Okay. So, we're going to take in the number. If 0, we are done. We will then outbox just copy from 0 and we'll label this buffer. Okay, so that's our logic. Otherwise, jump back to the beginning. Okay, so I feel like I should put a 0 in the buffer. What happens if we try to subtract something from buffer? Is that just going to error? Huh. Can we bump buffer? They didn't give me a 0. Okay, so we're not going to do that. We're just going to go ahead and copy that number to 1. Nope. I don't have any sort of if empty. I feel like I'm missing something here. So we're gonna... I mean, okay, so with the first... You'll never get an empty string. Okay, that's the point that matters here. So then we're gonna inbox again. If 0. So then this jump actually needs to go to here. This jump, oops. This jump needs to go back up to the top. Okay. So we're going to take the number we just took. We are going to subtract buffer. If negative, that means the buffer was larger. If negative, that means the buffer was larger. In which case, we should add buffer and copy to buffer. So we're going to add it back in, and then we're going to put it in the buffer. Otherwise, if the number was positive, we don't need to do anything except go to the next number. How are we getting here? There. That's not gonna work. There. That's better. Okay, let's try it. Empty value. Go ahead and put this in the buffer. Nice. 13 or fewer. We did it in 13. I like it when I get it on the first try. Got both of them on the first try. Woohoo! Continue to elevator. Oh, mod module. I don't want a mod. We're gonna do division now? I tell you, not enough. There's always a sad reminder of unworked hours. Good thing we have these optional night shifts. Okay. For each 2 things in the inbox, outbox the remainder that would result if you had divided the first number by the second. Don't worry, you don't actually have to divide. And don't worry about the negative numbers for now. Yeah, okay. We'll copy it to 0. Copy that to 1. So this is x modulo y. So if negative, do that. Otherwise, jump back up to here. Here's what we're going to do. We're going to copy from 0, sub 1, sub 1. We just do that. Keep subtracting 1 unless it's negative. Then we're going to add 1, outbox, I think that's the game. Modulo's not too bad. I'm pretty happy with myself. Either I'm beginning to understand assembly, or look at that, I'm a whole command underneath the challenge. And fast. This guy, if this was a high school assignment and being used in a high school classroom, I would have just gotten an A. I'm happy with that one. So how's everybody doing? What should we talk about? What other news is there in the world? What type of video game should I make on stream if I'm going to do video game making on stream? For each thing in the inbox, outbox the sum of itself plus all the numbers down to 0. Okay. Inbox. So we get the 4. We're going to copy that 4 there. Then we're going to copy that 4 nowhere else. Then we're going to add that number after we decrement it. If 0, we're going to outbox, jump to there. So Nope, this is a problem. We gotta store something somewhere. Finished the majority of your new test gear cataloging today, working on processing images of the cards in the data general to use for diagnostics. Nice. Ooh, should I tell you guys about my... So I've been trying, and I've mentioned this on stream a few times already. Well, we all know that I go to Disney way too much. And I know that I want to create Ears 2.0, but Ears 2.0, I am missing my inspiration to do it. Or the style that I want to do it. And today, something caught my eye. In fact, I'm gonna show you guys. It's not all that cool, but it'll get me, talking about something. So today they released a pin, and I didn't know that they were releasing this pin. Otherwise, I would have sent somebody to go buy it for me because I would have wanted it. But I'm sure I can get it on eBay in like 3 months, and it'll be like $15 or something. But here's the button. So they released this pin today, which is the Pizza Rizzo pin, and this pin is based on a sign which you can kind of see blurred out here that is above Pizza Rizzo, which is my favorite place to get pizza in Hollywood Studios. Now, this pin wouldn't normally be that big of a deal for most people, except Pizza Rizzo's is going to be shut down in like, I don't know, 2 months, something like that. It's not, Pizza Rizzo's does not stand to live much longer. And so at the moment, there's a little bit of hype about people wanting to remember the last time they had pizza at Pizza Rizzo's. Now, as I already said, Pizza Rizzo's is one of my favorite places to eat. And even though it's like lunchroom cafeteria pizza, but the sign on the outside is a nice neon sign when you see it, but at night they have a little Muppet gag, and this is what it looks like at night. So these lights right here shut off, and it ends up saying it's rat pizza. Right, which sounds delicious, right? Rat pizza. So it's a little gimmicky thing. So I was like, I should make a set of ears that have something to do with Pizza Rizzo, and because I love it so much. And then I was like, you know what? It sounds like a good idea, but I think I can do better. And I was like, I should make a shirt that is dedicated to this sign. And what I came up with was taking, I can't think of the EL sheet panel. So they make, some of you are probably familiar with EL wire. There's another version of it known as a panel, and that's what these are. And I haven't ordered it yet. I should probably do that because I'm running out of time already. But these EL panels can be cut, and like you can make them do what you want them to do and shape them the way you want to shape them. And I don't think this is one that can be cut, actually. I think this is one that has a border, but there are ones that can be cut. And so what I want to do is I'm going to print a translucent sticker, semi-translucent sticker, like that looks like this. And then I'm going to cut holes, or I'm going to make it solid where it's dark. I'm going to use translucent color where there's neon, right? And then I'm going to use 2 EL panels with one of the panels cut out, right here along the edge here, so that I can turn the words on and off like the sign actually does. So essentially I'm going to recreate the sign on a shirt. And hopefully it would look really cool. And if it's small enough, I'll put it on a hat. But right now, I'm thinking that it's going to be like a, like 5 inches by 5 inches, which I guess, you know, that's not necessarily horrible. It's not going to be 5 by 5, but something like that, 5 by something. So yeah, that's my latest Disney project. It's silly, but I think it'd be cool if I can pull it off. I think it would look really cool and it would be unique, and I could wear it to any of the parks and people would probably be impressed by it. So that's my latest weird project, if you will. So do. I think that'll work. Nope, somebody made a mistake. So we never checked. Let's do that. Except we need it. We need it in both spots, I think. By outbox 2. Okay, so let's figure out where the math went wrong. Okay, so we grabbed it, 4 came in, we put the 4 there, great. Change that to a 3. We added the 4. We added the 4. And then we save it back, and we do that all over again. Oh, we may have forgotten the main loop. Which is not unusual for me. Get it working for one thing, then get it working for everything. Hey, success! Got it on 12. 95. Oh no. Is there something obvious we could do? Multiple 0 checks. Copy to 1. That's not going to be 0. That check doesn't need to be run multiple times. It could be here. Try that out. Mm-hmm. 85. Jump if 0 down to there. Has to copy from there. Add 1. Copy to 0. Yeah, that has to happen. We're only 3 away, so what can I... This one, jump if 0, jump if 0. So there were... That makes sense. That makes sense. What if we move the bump to here? Make this go away. Where'd the add come from? Copy 2, 1. Bump 0. Oh, that might actually be it. Let's watch the math again. See what I did wrong. Okay, 4 came in. We shouldn't have done that. That should have been a 0. Okay, let's try this one more time. We're still on 12. That added commands? Wasn't I only 3 away? How did that add commands? Take the number, we subtract... Oh, if it's 0... No, we want the jump if 0. That belonged there. We add 1. Copy it to the 1, then bump the 0. Loop. I don't understand how that added. Add 1. Add 1, copy to 1. We never have to load from 1. We didn't have to... We had that number. Add 1, but there's nothing in 1. Copy to 0. So if the answer is 0, okay, get the number, put it there. If it's 0, which it's not in 1. If we copy it to 1, somehow the old one, by doing this, it saved me time. So if 0, what are we currently holding? The number. So if it's 0, do that. But that's not going to be the right answer. Except it is, because it's 0. So that's fine. So then we add 1, which is, it's 4, they're both 4. So add 4, copy to 1. So now we're at 8. We subtracted. So if the number is 1, put a 1 there, we put a 1 there. We're now at 2, which we don't want to be. I'll try this. Feels like the old code. Yeah. Except now we've added a command in there somewhere, and we picked up... So we loop unrolled that one step. So what if we move this to here, make this go away? Bump 0. And we add the 1. And we copy to 1. I don't know how I feel about this, but let's see what happens. Feels like the same code, but we moved the bump. Okay. And we picked up 13. I don't get it. Okay. Back to the elevator. Worry about optimizations another day. Let's look at Midnight Petroleum and see what this one's looking like here. What's our cutscene? I feel like there's some significance to these cutscenes, but I don't know what it is. Is that the moon? Did you guys see the stars last night? And by stars, I mean planets. There's like 4 or 5 planets in the sky right now. And they're kind of lined up. Or at least they were last night. I don't know if they are tonight. This is getting weird. Feels artsy. Okay, career milestone, we got an achievement. Okay, we're getting there. Slowly but surely. Real quick, before we wrap this up for the night, I'm just kind of curious. How many achievements are there? There are 16 achievements. I'm just going to read through the ones I don't have yet. So, glorious failure. Solve a puzzle for a specific set of inputs while still failing with other possible inputs. Okay. Intriguing. Orange optimization award. Venus is super visible. Yeah, it's like last night it was... Actually, I don't know if we could see Venus last night. What's the map? Google Maps for stars, though. Google Maps for stars. What is that program called? Sky Map? Yeah, but there's a really good one that I like. For PC. Is it Sky Map? It was... We used to install it on all the school computers. Stellarium. I think that's what it is. Stellarium. Yeah, I don't have it installed on my computer anymore, which is kind of a bummer. Okay, where does it think I am? Here, we'll put it on the screen. Yeah, so right now, and this is what I was talking about. So yeah, Venus last night when I looked was just below the horizon, so I couldn't see it, I think, at the time I was looking, which is about 2 hours from now. I looked at it at like 10 o'clock last night. Ooh, what's this? Cosmos. That's why I love it, because it's got like all the satellites and stuff that you might see flying by. So Venus, Uranus, Jupiter, Mars, and I thought there was one more last night. Maybe there was, but I don't think... I guess I'm not seeing it now. But, yeah, if you're somebody who likes to look at the sky and you've got a good view tonight, you should look at the sky in your area and see what's hanging around. But there's Orion. But you can like zoom in. I mostly like looking at this to figure out where the International Space Station is. or when it might come by. But in any case, filter for planets. Oh, is there a planets tonight? Oh, look at that. Yeah, so Saturn was there briefly. So basically, lots of planets in the sky. Is there no moon tonight for me? Is it a new moon? Oh, that's probably why they're so bright. I didn't even think about it. These are little things that you should, like, really think about when trying to figure out why the stars seem brighter for some reason. It's because there was no moon to whitewash them out or whatever. So, in any case, let's hop back to the game here for a sec. Make sure that we saved and did everything we needed to do. Exit game. Well, that's all we needed to do, I guess. So with that, we're going to go right Ninja Weasel Plays, who's probably playing board games, and see what's going on over there. So appreciate you guys. We'll probably still do this tomorrow because now I'm addicted. So if you don't like assembly programming, I'm sorry. Come talk to me about other things. There's a small chance we'll do something else, but it probably won't be a different video game. We might do some 3D printing or designing or something, depending on how the day goes. So in any case, stay healthy, stay safe, and until next trip, see ya.